Hi everybody, I am Javier, the team leader of Goons. So just a little bit of a fun fact from me. I'm a year two maritime studies in NTU and I specialize in data analytics. I think this drew me into this hackathon because I have a strong interest in vessels and especially the sea conditions. So I'd like to do something that may alleviate the situation of congestion in ports. A bit of an interesting fact. One of my favorite words is goons, and I like to say that I am from Serangoon, and that's why I am a goon myself. And one thing, an additional thing is that during my internship and during the summer, I noticed about how port congestions have affected shipping operations quite significantly, and that's therefore I feel it's a pressing issue, and we have to find a way to solve it. Yep, over to you, Dia.
Thank you, Javier. Hey everyone, I'm Dia, a year two maritime studies student with a second major in data analytics. So basically, I'm a huge nerd about ships and spreadsheets. And here's a fun fact to kick things off. I can name all 196 countries in the world. And yes, even the tiny ones like Nauru and Tuvalu. But don't worry, I'm not here to flex my geography skills. I'll save that for later. Instead, we're diving into something just as exciting: port congestion at PSA Singapore. This topic has been giving shipping companies way more sleepless nights than trying to spell Kyrgyzstan correctly. Over to you, Glenda.
Hi, my name is Glenda, and I'm a year two student at NTU studying maritime studies. I actually joined this hackathon because I was very interested in how AI and digitalization can help with port congestion. And one one fun fact about myself is that recently I've been very into Pilates. Yes, over to you, Glenn.
Yo, what's up? My name is Glenn, and I'm a year two student in data science and AI. So I think what drew me into this hackathon was actually Javier, but actually I think what interested me the most is the use of AI in a very wide range of topics as well as different kinds of jobs and industries that are happening all around the world, which I think through this code sprint, I was able to learn a lot more about the maritime industry, even though I really rarely had any interaction or any knowledge in this part. So I really enjoyed the process of PSA code sprint, whereby I could use my development skills as well as to pick up new skills regarding AI development. So now, shall we start with our introduction?
Having heard from the four of us, now it's time to hear from our slides. Let's go. Hey guys, so this is our slides for PSA Code Sprint 2024. Our project name is Please Ask, and this is by four goons, Dia, Glenda, Glenn, and me, Javier. On to the next slide. So this is the executive summary of our project. So we understand that there have been recent congestions at PSA-operated ports in Singapore, with waiting times peaking at 1 week in June. So this, of course, has posed significant challenges for shipping operations. To address this issue, our team has implemented a chatbot that provides real-time updates on port capacity and recommends alternative port calls and shipping routes. This helps to estimate potential cost and time savings for diversions, enabling clients to make informed decisions quickly. This solution enhances operational efficiency, reduces delays, and improves customer satisfaction. Next. So how is this relevant to PSA? In other words, how is this useful for PSA? So it addresses PSA's core objectives: improving operation efficiency, enhancing port resilience, optimizing resource allocation, and providing clearer and more accurate services to clients. So this is all part of a strategic objective to improve PSA as a more appealing port to future customers. Next.
Moving on, I'll now be addressing the current issue that PSA Singapore is facing. So currently, PSA Singapore is facing severe operational disruptions due to port congestion. This issue has caused significant delays in shipping timetables, leading to disruptions in the supply chain. What makes things worse is the unpredictability in port availability, which has resulted in late deliveries and shipping costs. So shipping companies are actually incurring extra costs just to keep their containers stuck at the port. To add fuel to the fire, quite literally, vessels are burning more fuel as they remain stationary, waiting for docking space. This in turn drives up operational costs for everyone involved. But what's behind all of this? It's largely due to a combination of insufficient berthing capacity and unexpected events like labor strikes. These challenges are piling up pressure on PSA's operations and sending ripples through global shipping schedules.
So what our solution offers will be a chatbot system where we will offer intelligent route planning. So what it will do is that it will collect details of shipments such as the port of loading and port of discharge and users' preference, whether they prefer to prioritize duration or cost. Then the dynamic port capacity management will help to consider real-time and predicted port capacities to avoid congestion. There will also be automated routing where we'll suggest alternative ports and routes when the port is nearing their full capacity, which we use 95% full. So lastly, we have a user-friendly interface which simplifies the complex routing process for clients so we can minimize their inconvenience and frustration.
So our solution makes use of a modified Dijkstra's algorithm to find the optimal path for clients, diverting if necessary when port capacity is near max. For example, when it's about 95% full. So the solution makes use of open source large language models from OLLaMA, includes Llama 3.1 as well as Qwen 2.5, and an AI agent library, AutoGen, that is created by Meta to essentially create a multi-agent team which helps users with their queries. So this is fully run on a Flask API, which allows for development of an API service that can be used as a backend for a certain front end. So our current prototype is a fully locally run solution, and it's more of a CLI, a command line interface, than an actual front end because of the time constraints. But with more time and resources, a front end can definitely be implemented to allow for a better user experience. And the reason our solution is better, I would say, is that the use of the locally run open source large language models show that even though with such smaller models, which have about 8 billion parameters as compared to the way bigger open AI source models such as GPT-4 and above, is that even though with these smaller language models, the AI can still be run and can give some results as compared to, let's say, the bigger models, which means that this is a fully scalable project. And if we have access to, let's say, larger language models or better UI UX development, we believe that the app can be a great solution to not just help port resilience, but also port efficiencies, as the requirement for a person to be there to essentially negotiate with the client is taken away and reduced as we have the AI in place for that. So the chatbot streamlines the shipping operations by offering an intelligent route planning, real-time port capacity management, as well as predictive, and also to reroute if, for example, the original optimal path were to go through a port which is at about 95% capacity. So it is able to gather key shipment information and then suggest the most efficient routes based on the current conditions as well as the user's desires. So we expect that this would be able to reduce port congestions if there was, let's say, a sudden surge in demand for example, PSA's ports or or in general global ports that are being used. And so the chatbot will automatically suggest alternative routes, potentially saving 2 to 5 days of waiting time that is caused by congestions.